All right, let's go ahead and look at another example here. This one's going to get a little bit more complicated because it's not a polynomial. Now we have a rational function. We can do the same thing, we just got to be really careful about our algebra. So I've said this before in other videos, you'll probably hear me say this again. One of the best things you can do to be prepared and to do well in calculus is to have strong algebra skills. We're going to find the derivative, and basically what we're saying here is find f prime, not of a, not only at one specific point, but find f prime of x. Find a new function that talks about the slope of the tangent line regardless of where you are. Now, I will say we want to be careful about one thing. Look at this function. What is the domain of this function? Okay. For a polynomial, the domain is all real numbers. For this function, x is not allowed to be -2. So it's just something good to keep in mind. X is not allowed to be -2. That's not even in the domain. So we're really not looking at f prime of x for all x. We're looking at find f prime of x for all x on the interval from -infinity up to 2 union 2 up to infinity. So 2 doesn't even count. We're not even including that value. It's just a good thing to note from the very beginning. But then we can kind of go do the same things. All right, so let's go back to our definition. We have the limit as h goes to 0 of f of x plus h. Be careful here. This looks like 1 minus x plus h divided by 2 plus x plus h. There's your f of x plus h part. And then minus f of x, which is 1 minus x over 2 plus x, all divided by h. Okay, so remember I said earlier that this is kind of like back when we talked about limits, and we said you're not allowed to plug in a value. How do I simplify? Okay, this one we don't just kind of factor, we don't just kind of hope some things cancel. We have some fractions here. This is going to get a little bit messier. Okay, so we can think about how do we deal with trying to simplify something like this. And no, you can't just add an h onto the second parenthesis or the second fraction over here and have a 2 plus x plus h on the bottom. Remember, to subtract fractions, you got to have a common denominator. So the way you should do that, I'm going to give myself a little bit more space here, is that you actually need to multiply both of those fractions by some fancy form of 1 that gets a common denominator. So this should multiply by 2 plus x over 2 plus x. And then the second one, which already was 1 minus x over 2 plus x, that one needs to multiply by 2 plus x plus h divided by 2 plus x plus h. So there's your multiplying by 1 and multiplying by 1, and notice now both of those fractions have a common denominator. And if you want to put all these, the numerator and denominator there in parentheses and kind of throw parentheses all over the place, that's fine. You're welcome to do that. So now this looks like the limit as h goes to 0 of, let's see, on the bottom of the fractions that are on the top of the big fraction, we're going to have 2 plus x times 2 plus x plus h for both of those. And on the top, you're going to get, 2 plus x times 1 minus x minus h. Notice I kind of distributed this negative there. And then minus, it's going to look like 1 minus x times 2 plus x plus h. Don't forget there's supposed to be a divided by h on the bottom of the whole entire thing, but another way to think about dividing everything by h is to multiply by 1 over h. So that h can kind of go on the bottom so that you don't have fractions inside of fractions, you just have one big fraction altogether. Doesn't necessarily make it less intimidating by a lot, but it does help us just a little bit just to kind of keep things straight. So I'm just going to put that h down here. So now let's see what happens. Hopefully some nice things happen. If it doesn't, we're a little sunk. So let's see what we can do. What I would recommend here, because now there's not much you can do at the bottom, I wouldn't even recommend foiling that out on the bottom. Some things might end up canceling. We'll kind of see what ends up happening there, but let's just leave the bottom as it is. So this is still the limit as h goes to 0 of, I'm just going to write it as 2 plus x times 2 plus x plus h all times h, and just leave that on the bottom. Now, where this is going to get a little bit stickier before it becomes better is you should expand over here on the left side, which means multiply 2 by everything that's in the second set of parentheses, multiply an x by everything that's in the second set of parentheses, and then do that again over here as well. And then you can go ahead and subtract, and hopefully a lot of things will cancel on the top, and it'll hopefully become a lot more simple. Now, that being said, I need to move to another whiteboard so I have enough space for this. So here's what that's going to look like. The limit as h goes to 0, again on the bottom, we're going to go ahead and just leave it as 2 plus x times 2 plus x plus h, all times h. Now on the top, if you've expanded everything correctly, you have a binomial times a trinomial in 2 different places. Here's what you should end up getting from that. It should look like 2 minus x minus 2h minus x squared minus xh. I'll go ahead and put that all in parentheses, and then minus the second parentheses is what we had from the second multiplication. So 2 minus x plus h minus x squared minus xh. The nice thing about this now is you're going to have a 2 here and a minus 2 there. You're going to have a minus x here and a minus x, so that's like a plus x. If you were to distribute the negative in here, all those are going to change sign. And so you have a minus xh, you have a plus xh, you have a minus x squared, you have a plus x squared. The only thing that doesn't quite cancel is what you're left with on the top. You should have something like negative 2h and then minus h. The minus h is from the negative multiplying by that one right there. Okay, so in other words, minus 2h minus h, I'll go ahead and combine those together. You get minus 3h on the top. So you should get something like minus 3h all divided by 2 plus x times 2 plus x plus h all times h. And notice, it's kind of like what we had before where everything on the top has an h in it. And fortunately, we didn't distribute and combine anything on the bottom. We just kind of left that, which is always a good practice in these, by the way. Go ahead and divide by h on top and bottom now. And now you have something like the limit as h goes to 0 of negative 3 over 2 plus x times 2 plus x plus h. Now, this is the first step where it is okay for you to go ahead and plug in 0 for h, because again, every other step we would have gotten 0 over 0. So when you plug in 0 for h now, you get negative 3 over 2 plus x times 2 plus x, or another way to write that is 2 plus x squared. There is our new function that we get from this. And again, just like in the last example, we shouldn't be surprised that we get an x in our answer. That's because you're going to have a different slope of a tangent line depending on which x value it is that you're talking about. So we're going to get a new function, but this notationally, this is f prime of x now. All right, let's go ahead and look at one last one. Again, this is all good practice, just dealing with different types of functions. This one, you might actually have a little bit more of an intuitive idea about what to do after I show it to you, because we've actually already seen a problem that's kind of like this. So let's say we have something like f of x equals the square root of x plus 2. Let's go ahead and try to do the same thing as before. The limit as h goes to 0 of f of x plus h looks like the square root of x plus h plus 2. Minus f of x, which is just your original function. And I hope you're getting a little faster of kind of writing these out and thinking about what the formula looks like and making sure that we can have our correct steps here to get started. So there's your f of x plus h minus f of x, all divided by h. Okay, and what you might see pretty quickly is that in this, you're going to have something cancel almost right away. Okay, because if we write this out, this is a square root of x plus h plus 2. If you distribute that negative, we get a minus the square root of x minus 2, all over h, and oh yeah, we have a plus 2 and a minus 2. That's kind of nice. Okay, so we have the limit as h goes to 0 of the square root of x plus h minus the square root of x all over h. But at no point can we go ahead and plug in 0 for h. That doesn't work. Now, we're still trying to simplify, okay? And so here's a thought is, have you seen this before where we have a limit of something with square roots in it? This should bring you back to a few videos ago where we were talking about limits with a problem with the square roots in it. And so what you might remember, if you remember that video, what you might remember is the way we dealt with that with limits, with square roots, was by using what we call the conjugate. Okay, so here's what I would recommend. And I told you in that video that conjugates are really helpful when we have square roots, and I said that those are the solution to limit problems with square roots like 95% of the time. So let's try that in here. If you take what you have as the limit as h goes to 0 of x plus h minus the square root of x all over h, multiply by the conjugate on top and on bottom. Remember what a conjugate is, right? The square root of x plus h, and then change the sign in the middle, so plus the square root of x, and you got to multiply by that on top and on bottom, because you got to multiply by some fancy form of 1. So there's your 1 that you're multiplying by. And so now you have a conjugate on top and on bottom, okay? And hopefully this should end up working out, or at least if you trust the fact that I told you that 95% of the time this works. You go ahead and multiply out on the top and FOIL out those two pieces on the top and see what ends up happening. Some nice things should happen. You can go ahead and pause the video, see if you can run with this and do the algebra on your own. I will still walk through it, of course, but you should try this on your own, okay? So remember what we're finding is we're calling it f prime of x, so we still have a limit as h goes to 0 of, let's see, we had the square root of x plus h minus the square root of x, and we were multiplying by the square root of x plus h plus the square root of x. I'm just kind of rewriting the same steps that we had before, and then it was h on the bottom times the square root of x plus h plus the square root of x. All right, and then on the top, we should have some nice things happen. Square root of x plus h times square root of x plus h is just x plus h. And remember, the reason we were using a conjugate is because when you do the O and the I in the FOIL, the outer and the inner, those should cancel each other out. You should have exactly the same terms, but with opposite signs. So the only thing we need, let's see, this is supposed to be a square root of x, not a square root of h. I copied the problem wrong. And so we have the O and the I cancel, and then when you do the last ones, we have a square root of x times a square root of x. That should give you a minus x. Okay, all divided by h times a square root of x plus h plus square root of x. Okay, and now we have on the top, you don't have any more square roots left over, and now you have a positive x and a minus x, and so you should be left over with just an h on the top. I hope you're recognizing that as a trend, by the way, is that somehow you should be able to get to a point, hopefully, of having just an h or an h be able to factor out and then cancel that with the h that was on the bottom at the very beginning. So we have h over h times, this is the square root of x plus h plus the square root of x, so on and so forth like that. Now the h's can cancel, and so we have the limit as h goes to 0 of 1 over square root of x plus h plus the square root of x. And now it's perfectly fine for you to plug in 0 for h. And once you do that, you get 1 over, let's see, h is just 0, so you just get the square root of x plus the square root of x, or another way to write that is 2 times the square root of x. Okay, which, by the way, you can write this in a couple of different ways. Or you could write it as 1/2. This could be the square root of x on the bottom, or you could write it as x to the negative 1/2. I told you in a previous video that it's going to be really helpful to be able to convert back and forth from fractions to negative exponents like this. So a couple of different ways you can write your answer there. But again, shouldn't be surprised to get an x in your answer when you're finding f prime of x, because we're talking about the derivative for a lot of different values of x. Okay?